Hello, and welcome back to Shiksha DaCosta. Today we're going to learn how to graph quadratics from their standard form. In this lesson, you'll learn how to sketch the graph of a quadratic relation when it's given to you in its standard form ax squared plus bx plus c. You'll pick the best strategy to do so, and you'll be able to tell what are the key features from the graph. As part of this lesson, you'll also be able to figure out what information you can get just by looking at the equation in standard form or in vertex form or even in factored form. To start off, I'd like you to open up some graphing technology and graph these three functions and ask yourself, what do you notice? You can pause this video here while you do that. Well, this is what these three functions look like. And if you've watched one of my previous videos, you will have seen this already. The thing to notice in this situation is, hey, all three of these, are all the same. There actually is something else to notice. If you look very closely and you compare the equations to the actual graph, you might start noticing that some of the numbers that show up in the equations actually show up on as points on the graph, and they're very important points too. For example, over here we've got the vertex. This is why we call this vertex form. We can see the location of the vertex right by looking at the equation. The 3 and the -1 are both there. We can see in this equation, we can see that these two very important points, the x-intercepts or the zeros, are clearly evident just by looking at the factored form of the relation. And finally, the standard form of the function can tell us the y-intercept. Notice that that 8 is the same as that number here. The question really here is, will this always be true? Is this number at the end here always going to be the same as the y-intercept? The y-intercept, just by its definition, is a point on the graph where the graph crosses the y-axis. And any point on the y-axis, right, if this is the y-axis, we go down to where it meets the x-axis, it will always meet it when x equals 0. So any y-intercept at all will always have an x-coordinate of 0. So if we want to find the value of y, we just take the value of x that we know needs to be equal to 0, and we can plug it into the function. We just need to find f at 0. And if we had a quadratic in standard form, f of x equals x squared plus bx plus c, and we were trying to find out f at 0, well, we would have to replace x and x with 0. Now, if we evaluate this, we'll see that, okay, it doesn't matter what a is, anything times 0 will be 0. Same for b. But c is not being multiplied by 0. C is just going to be left all on its own. And then when we add these all up, 0 plus c is just c. So yes, in fact, that ending number here, that c value, will always tell you the y-intercept. In fact, all three forms of a quadratic function all give you some sort of information about some point on the graph. The standard form, like we just saw, tells us that the y-intercept is always at 0 and whatever the c value is. If we wanted to convert from standard form to vertex form, if we completed the square, we would get vertex form. And from here, we can easily look at h and k to find the location of the vertex. If we wanted to revert back to standard form, we would just have to expand and simplify. From standard form, we could, of course, turn this into factored form by factoring the equation itself. And then the two values here will be the zeros, right? Any value of x that makes any of these factors equal 0. And if we wanted to go back to standard form from there, we can expand and simplify. Notice that from vertex or factored form to get to standard form, you just need to expand and simplify. Now, these are 4 very important points. And the more points you have, the more accurate and the easier it will be for you to sketch a quadratic function. The only caveat is not every quadratic function has real zeros, so factoring sometimes is not an option. There may not be any zeros for your graph at all. In that case, the y-intercept and the vertex are probably best. Let's see this in action. Let's sketch the graph of f of x equals x squared plus 6x plus 8. Now this is standard form, and like we just talked about, it's really easy for us to get the y-intercept. It's this number right here, 0 and 8. So I can put my coordinate right over here where x is 0 and y is just about 8. This would be about 7.5, so 8 is just a bit higher than that. We can then take this equation in standard form and we can factor it to turn it into factored form. So let's see, 8 times 1 gives us 8, but that's not it. We can't get 6 out of 1 and 8. What about 4 and 2? 4 times 2 is 8, and 4 plus 2 is 6. So in fact, these are the factors we're going to use, and this will just factor into x plus 4 and x plus 2. And this tells us right away that the zeros are going to be the opposite signs of whatever these numbers are. So -4 and -2. And let's plot those on our graph right now. Finally, we can take this equation and we can start to complete the square. Remember, to complete the square, we're looking at these first two terms and asking, what does the third term need to be for this to be a square? It's always going to be half the value of b squared. So half of 6 is 3. 3 squared is 9. Unfortunately, this is not a perfect square trinomial, right? This would have to be 9. So what we can do is we can add 9 and subtract 9. And this is kind of like adding 0. And that way we can look at these three terms, and this will very easily factor into x plus 3 squared. It's always going to be half this number. X plus half of 6 is 3 squared. At the same time, we can combine these two numbers. 8 and -9 combine into -1. And this is vertex form. And that tells us that the vertex is going to be right over here at -3 and -1. And using these 4 points, we can just connect them with a nice smooth curve, and boom, there's our quadratic. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.